On the 21st of September 1974, the first prototype of the Anglo-German-Italian Panavia Tornado multi-role combat aircraft took off from the flight test center at Manching in southern Germany. Representatives of the three nations met to celebrate the launching of this European project, and the three governments confirmed publicly the success of their joint efforts. First, the German Minister of Defense, Georg Leber. The Tornado's takeoff followed 6 years of political, economic, and technical evolution. Following a NATO review undertaken in 1968, it became clear that many combat aircraft types currently in service would be outdated. It was also clear that some NATO forces would have to replace their existing weapon systems simultaneously. The defense policy of European NATO countries is based on the principle of flexible response. Nuclear response to a conventional attack has to be delayed for as long as possible. In addition, Eurogroup has called for the maximum standardization of NATO equipment. For financial and operational reasons, NATO has to standardize not only equipment, but spares and logistics, because purely national products are uneconomical. Consequently, every of the largest aerospace companies in Europe were chosen to design, develop and produce the new aircraft. British Aircraft Corporation in Great Britain, Air Italia in Italy, and Messerschmitt Bölkow Blohm in Germany. They had had many. The three companies, Air Italia, BAC, and MBB, got together, pooled their expertise and their technical and financial resources, and founded Panavia Aircraft GmbH on the 26th of March 1969 to design, develop and produce the Tornado multi-role combat aircraft. The three governments of Italy, the UK and Germany also got together and formed a joint governmental organization, NAMO, with its agency NAMA, in the same building as Panavia. Industry, represented by Panavia and its parent companies, became a main contractor to this NATO organization. A trinational engine company, Turbo Union Limited, with Fiat in Italy, Motoren and Turbinen Union in Germany, and Rolls-Royce in the United Kingdom as parent companies, designed, developed and produced the Tornado's engine, the RB199. IWK Mauser is the main contractor for the development and production of the Tornado's gun. The work sharing of Turbo Union, which produces the engine, is as follows. Rolls-Royce, the high-pressure turbine, the low-pressure compressor, the turbine casing, and the annular combustion chamber. MTU makes the intermediate pressure compressor, the engine-mounted gearbox and thrust reverser, and Fiat the low-pressure turbine and the variable nozzle. Basic roles for the Tornado. Battlefield interdiction. To halt advancing enemy armored columns, which calls for quick reaction air-to-ground operations. Enemy ground-to-air defenses are evaded by flying very low in all weather conditions, and the enemy is stopped by using the most modern air-to-ground weapons. Interdiction strike. striking deep into enemy territory at low level to knock out communications, power supplies, and industrial capacity. Interception. The air defense variant of the Tornado will be equipped to find and destroy enemy bombers attacking cities, bases, and other vital areas. Air superiority, maintaining control of the airspace over a battle zone. Naval strike. This calls for land-based operations against coastal and sea targets. High and low-level reconnaissance. In addition, a dual-control Tornado will be used for conversion training.
The aircraft has a crew of 2. The Tornado possesses first-rate STOL capability thanks to an excellent power-to-weight ratio, slats and flaps, and thrust reversers. By using variable geometry, the Tornado's speed ranges from very slow for landing and takeoff to transonic at low altitude and Mach 2 at height. In addition, variable geometry gives the aircraft extended endurance capability. The 2 turbo Union engines combine high power, excellent fuel economy and small size. Twin engines can mean survival in combat and safety in peacetime. Thrust reversers give a short landing run. Variable geometry, flaps and slats, and the fly-by-wire control system result in extremely good maneuverability. By flying at low level and high speed, enemy ground-to-air defenses can be penetrated. Yet the efficiency of the crew is maintained because of the aircraft's low gust response. The Tornado can carry a heavy weapon load consisting of a wide range of existing or projected air-to-ground, air-to-ship or air-to-air weapons. It can operate when no other aircraft can take off. Its radar enables it to follow a planned course automatically in all weather conditions over or round hilly ground. Its avionics and radar represent the most advanced technology tailored to the difficult operating conditions that prevail in Europe. Maintenance is facilitated by the speed with which engines and subsystems can be changed.
Tornado development represents not only a leap forward in aircraft technology and logistics, but also a common program for hundreds of companies and tens of thousands of workers all over Europe. The Panavia Director of Program Management, Dr. Ian Hall, has this to say.
Panavia.
Development is controlled on a day-to-day basis by the 3 governments and their agency N.A.M.O. The program is monitored by means of checkpoints. Before money is released for the next phase, industry has to demonstrate that costs, time schedules, and technical requirements have been met. 9 prototypes are now proving the technical feasibility and performance of the Tornado. Four are in Great Britain at BAC Military Aircraft Division's Flight Test Centre at Wharton. Two at AIT's Flight Test Centre at Caselle in Italy. And 3 in Germany at NBB's Flight Test Centre at Manching. The success of the flight test program has already proved the value of advanced detailed planning and extensive ground testing. In the interests of flexibility, the program makes provision for the interchange of tasks between prototypes at short notice. Some of the flight test results have exceeded expectation, and test pilots have commented most favorably on the aircraft's outstanding handling qualities. The flight test program has confirmed that the aircraft is ready for production. Dr. Renato Zassi is Panavia's Director of Production. The Panavia Tornado is a new aircraft in European skies, blazing the trail of European unity. An aerospace project of this size can only succeed by unity, by the rationalization of military requirements, by the integration of industrial capacities, by technical, economic and organizational standardization within 3 countries, by a combined industry-government management system, and by common cost control. The Panavia Tornado, Europe's answer to the defense requirements of today and tomorrow.